So if I want to find the value of this, it's called evaluate this. It's also simplifying. What I first want to realize is, can I reduce that fraction? So the first thing you should notice is, yeah, I can reduce that to 25 fourths. Then, if you know your radical properties, you're allowed to break that radical into two individual radicals. You're not breaking any mathematical rules by doing that. You can break that into two unique individual radicals. And then, the square root of 25 is 5, and the square root of 4 is 2. That right there, which is 2.5, is an equivalent value to this. These are equivalent. Now, let's look at the next one. Well, 64, the square root of 64 is 8, but would that negative mess me up? No. You could just take the square root of 64, which is 8, and make it negative. So the answer is simply negative 8. But with this one, if the negative's inside, there's an issue. The square root of negative 81 is impossible. It's imaginary. So for this one, the answer is undefined. Now, if you're talking with imaginaries, yes, the answer is 9i. But assume we're not talking about imaginaries, but if you were, it'd be 9i. But assuming in real numbers, it's undefined. There is no answer for that particular square root. Now, to simplify this one, let's think of that. I'm going to break that up into a whole bunch of square root of h squareds. Now, that might be a little confusing, but watch. The square root of h squared, are you okay that equals h? But watch this. If I have the square root of h squared repeatedly, think about, let me finish writing all this. Think about that right there. Isn't h to the 10th really h squared, h squared, h squared, h squared, h squared? Won't 5 h squareds equal h to the 10th? Now, what do each of these individually equal? Well, hopefully you can understand they all equal h. So, what is my answer? My answer is h to the 5th. So if I have the square root of h to the 10th, it's really h to the 5th. Now, there's a lot easier way of doing this. Here's why it's easier. You're going to kind of like this way a lot better. Can't you technically put a 2 there? And call this h to the what fractional power? Is it 10 halves or 2 tenths?
10 halves.
It's 10 halves. So won't that right there equal h to the 5th? That's a lot faster. So this right here is a quick way, but knowing this is important to understand where it comes from. So for this last one, I'm going to do very similar to this, but a little bit extra step. So what I'm going to start with here is, let's just start with the square root of 100. And then let's break up a to the 8th. Isn't a to the 8th going to be the square root of a squared times the square root of a squared times the square root of a squared times the square root of a squared? Now, from that, can each one break down to something unique? Yeah. The square root of 100 is 10. The square root of a squared is a times a times a times a. So my answer is 10a to the 4th. But now that is a long way of doing it. There's a lot shorter way, a kind of quicker way using fractional powers. So watch this. With fractional powers, I could write the square root of 100 times a to what fractional power? We'll put a 2 there. 8 over 2. Can you see how that equals 10 a to the 4th? A lot easier to deal with fractional powers than drawing all this mess. But the mess is how it's done. If I want to simplify this or evaluate it, well, what cube gives you negative 64? Hopefully you realize that would be negative 4, because negative 4 times negative 4 times negative 4 is negative 64. That's it. Again, because here's what you're technically doing. That equals negative 64. Done. Now, if that was a square root, it's not possible, because even though the square root of 64 is 8, you can't have negatives inside. Now, the next problem, well, can the fraction reduce? 125 divided by 8? No. But I could break this up into two unique cube roots. You're allowed to break it up into two unique cube roots. And you need to start memorizing your cube roots or recognizing them, because 125 is a perfect cube root, which is 5. And 8 is a perfect cube root, which is 2. So there's your answer. Last one, I have fourth roots now. So let's break it up into two unique fourth roots. I have the fourth root of 81 times, well, I want the fourth root of a to the fourth, because isn't that equal to a? How many of those do I need? 6 of them, because 24 divided by 6, man, there's a whole bunch of them. So I've got to write a whole bunch of a to the fourths as fourth root of a to the fourths. So that's 3, 4 of them, 5 of them, 6 of them. 1, 2, 3, 4, 5, 6. So now, fourth root of 81, I hope you understand, is 3. If you don't, multiply it a couple times, you will see. And each of these are an a. So you have 6 a's multiplied together. So my answer is 3a to the 6th. Now, yes, there's a lot easier way. Other way would be, well, let's think about it. The fourth root of 81 times a to the what fractional power? 24 fourths. So that would be 3, and 24 divided by 4 is 6. That is a whole lot easier with fractional powers. So make sure you understand the bigger idea, but the fractional powers like this do speed you up.